So yes guys, so last time when I made a video on CMake fundamentals step by step with some basic example part 1, so you see there are a lot of views. So I got almost like around 25k views. So it has been almost like 3 years I haven't been uploaded any kind of a videos. And also I see a lot of you people are asking like where exactly the part 2, so where exactly it is coming and all those stuff. So that's why I decided that let's make a full-fledged CMake tutorial. So basically here we will be learning step by step. So it's like a baby steps. So I'll be teaching you about like what is the CMake, how this make file works, and what exactly the generation part, and what is this compilation and all this stuff. So we will be starting with the CMake tutorial step by step. And this will be a complete kind of a baby steps you can see. Now, in order to understand about the CMake, so basically we need to understand how the C and C++ compilation works. So that is the first basic fundamental step. So without even understanding what exactly and how exactly the C or C++ compilation works, it is very hard for you to understand about the make file or what are all the steps involved in this make file. So if you do not understand some little bit about the make file, then it is little bit difficult for you to understand the CMake. So that's why let's begin with understanding about the C and C++ compilation. So this is the baby step number 1. So this is where we are going to start. So let's begin. So here I have a VS Code, so which has been installed. And if I go to extension, so basically I installed C++ extension from the Microsoft. So here can you see C or C++ extension. So I highly recommend you guys to install this one. So because it will give all the intelligence and so many other stuffs. So let me zoom in bit. So let me close this chat. I'll zoom in bit. So then let's start creating. So let's create a folder called baby step 1. So then we'll create something called main.c. I'll be starting with a C program. So later on slowly we will change this one to C++. Let me write a simple hello world program. Yes. So here where my simple hello world program, and also I had given an example of a hash define. That's it. So basically what this program is doing is, so here we have a int min and it is printing hello world and it is printing test and the value which has been hard coded here, which is nothing but 1. Now let's go to my terminal and let me execute. So let me zoom in a little bit. So whenever you are compiling, so just give save hyphen temps. So then you give your source code name. So it is like baby steps. So before that one, so let me go into baby steps 1 and let's say gcc hyphen save hyphen temps. Then give your C source code. So when you do this ls, so here where you can see all the intermediate steps, so which is been done during the compilation stage. So what exactly all this thing? So the first thing is the compilation pre-processing stage. So in this stage, what exactly happened is, so all this source code, so it will see the compiler see all the source code and it will see the include. So basically here stdio.h. So when I click on this one, can you see there are a lot of source code. So basically this is the content of the header. So what it will do is, so it will do Control A, Control C, then it will come here. So it will paste the entire source code. Again, it will go here and again it will search. Is there any header file included? Yes. So click on this one, Control A, Control C, then again come here, I'll replace this header file. So like this, the compiler keep on replace whatever the header files which is been included. So recursively, it will go to all the header files. So it will copy the content and it makes kind of optimized. And then all the contents of this header files has been copy pasted into this source code. Then the second thing what it will do is, so whatever the hash define you have done, so wherever the hash define is there, so everything it will do a copy paste up. So that means the test will be replaced with 1. So this is the first stage of a compiler. So that is called an intermediate stage. So all this .c source code will be converted into an intermediate file. So this is where we are getting main.i. I'll open this one. If I scroll to the end, can you see our source code is only starts from line number 822. And here where you can see hello world \n and there is a %d1. Can you see this one is getting replaced? Then rest everything whatever you are seeing here, so it is all coming from the header files. So basically it is literally a copy paste job. This is called compilation pre-processing stage. So once after the compilation pre-processing stage is done, so it will take this source code, then it will convert into an assembly code. So this is called main.h yes file. So when I open this one here, can you see? So this is what the assembly code which is been written for my hello world, printing the hello world and also printing test and the value which is getting printed here. So this is what exactly it is happening. So basically this intermediate file is converted into an assembly code, and whatever the assembly code which is generated for this one, right? So it depends on the architecture. So that means if you are working with the x86 architecture, so in my case, I'll say uname minus am. Can you see here? So it is ARM architecture 64-bit. So basically my system is a ARM based architecture. So that's why the assembly code, whatever which is generated, it is for ARM architecture. So in your case, if you are working with the x86, so x86 based assembly code will be generated for you. And also one more thing, what exactly happen is, so whenever there are some compilation error, so this compilation error will be checked now, not in the pre-processing stage. So that means if I delete all this code, so let me delete all this thing, and I introduce some compilation error, which is nothing but a semicolon which has been missed. So then what I'll do is, so even let me delete this intermediate file as well. Then I'll go compile it again. The moment I compile this one again, can you see already there is a compilation error? So that means I'm missing a semicolon. Then when I go back to my folder here, can you see the intermediate file is generated? So that means first stage of a compilation. So it does not even think or look into a compilation error or a syntax error. So simply it will close its eyes and it will generate the intermediate file. So that is where here you can see there is a semicolon which has been missed. And the second stage, whenever it is trying to generate an assembly code, it started generating, but it encountered a syntax error in your source code. That is where the compilation terminated. It stopped there itself. So now let's go and fix this. Again, compile it. So now if you see, the intermediate file is generated successfully, and assembly code for my particular architecture, which is nothing but an ARM architecture, this is also been generated successfully. Once this is done, the compilation next step is, so from this assembly, whatever the assembly code which has been generated, it will convert into an object file. So this is the object file, so which you cannot read. So simply if you open this one, so there is something called ELF. So basically it is in executable and linkable format. So this is where basically an object file, whatever the source code which is written here, so this is being converted into this piece of object file. And once after this object file is done, the last part is a linking stage. So what exactly the linker will do? So basically what exactly it will do is, so this printf, the guy, like someone like us might have wrote a program for this printf as well, right? So where exactly the definition of this printf? So basically this std.io.h, so this header file contains only the declaration. So that means it will contain like what is the exact, the arguments and all those things, exact signature of this printf, but it does not contain the actual logic of printf. The logic of printf is present in something called a libc. So that libc has to be linked with object file in order to generate your a.out, which is nothing but your executable. Now I'll close this one. So let me go here and execute a.out. Can you see hello world and test1 is getting printed? And what are all the libraries which is getting linked to my binary? So which you can see is using LDD a.out. So once you do this LDD a.out, can you see these three libraries is being linked? So that means a.out is being linked with this one. So whatever the main.o object which is generated, right? That main.object and these three libraries, so everything's linked together, then it will generate my a.out. So this is how the compiler works. So these are all the different stages of the compilation, so which you have to know in order to understand the CMake better. So basically make better. So if you know how to write a simple make file, then it is very much easy for you guys to understand about the CMake. So yes guys, so this is the basics about how the compilation works, and this is the fundamental for understanding the CMake. So let's see in the next video what exactly we are going to